Hello and welcome to Dr. T's Math. In this video we'll look at radicals and indexes or exponents in a little bit more detail. At the top we've got some laws of exponents. If we have a fractional exponent like b over a, I like to think of the top and bottom as the green part and the root of a vegetable, and the divide by sign is the ground, so that a down there is the root, and then b is what's raised, or what we're raising x to. And so if we're raising all of that to the a power, everybody should know that the square root of x squared is equal to x, or that the cubed root of x all cubed is equal to x. Or in concrete terms, if you want to think about numbers, how about if we had the square root of 16 squared? Square root of 16 is 4. 4 squared, 16. Same holds for any number with any root. That if we raise a root to that same power, then what we're left with is what's inside that radical there. And so a lot of times that b is just going to be 1, and so you won't see anything. So like if I had 25, the square root of 25 to the first power times 1 plus 0 all over 1, then a lot of these things we just don't need to say, all right, because go on to infinity with this, to all of these numbers. A lot of things we just don't need to write. The 2 there, for example, and then the 1 exponent and the times 1 and the plus 0, because these are all identity properties. So we're left with the square root of 25 there. But I digress. Let's look at the statement before us. The square root of x plus 1 is equal to the square root of all that, 9x minus 2. I don't see any way to split these up into parts. Since we have a subtraction there, we can't just say 9x is the square root of 9 times x or anything like that. What I mean is, though, I can't say the square root of 9 times the square root of x minus 2 or 3 root x minus 2 or anything like that, because there's clearly that minus sign between these things, and there's something happening to all of these things together. So we can't split them up. But what we can do is square this side and square this side in order to get rid of this radical sign there. And so we're going to get, I know there's going to be an urge to say this is equal to x plus 1, right? Just drop down that exponent to both. But we have to treat it like it's a binomial and expand using the FOIL method or the box method or whatever everybody's most comfortable with. And what we're going to end up with is x plus 2 times the square root of x plus 1 is equal to, just get rid of that radical sign on the other side. It's equal to that. And then I think there's going to be a strong tendency to try to just move all x's over to one side, get a 0 or something there, or maybe a number, and then just x terms over here. But we are going to have to deal with this problem of whole number and fractional exponents, difference between those two terms. And so, step forward, I'm just going to get the square roots on one side and then put that against the whole numbers and whole number exponents over here. And we've got a couple of different ways to go about this. So what I first thought was to divide by 2. We get 8x minus 3 all over 2, and then we're going to square everything, and we get x is equal to, carry out all the operations, 64x squared minus 48x plus 9 all divided by 4. But then we just have to multiply everything by 4 again and subtract x to get 64x squared minus 52x plus 9 is equal to 0. We could have skipped the q right here by just squaring both sides now. And then we'd get 4x is equal to 64x squared minus 48x plus 9, and then we're just skipping a step. You can see that it's the same thing. It's going to end up back to the same thing as that. Either way you get there, that's fine. And so you could plug that into the quadratic formula, and you're going to end up with something like, remember the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Check, make sure that our b squared minus 4ac is going to be at least 0. What do we get? B squared negative 52 squared is the same as 52 squared. That's 2704 minus 4ac. Oh yeah, we're in the clear there for sure. All right. And so carry out the math. And what you get is x is equal to 9/16 or 1/4. And you can check that. I always like to go online and just kind of snoop around. At least see if I got the right answer. If not, get some parts of the problems taken care of by these wonderful tools. 64, next one is negative 52, and then we had 9, right? Sure enough, 9/16 and 1/4. All right, so generally speaking, we would just quit. We say, all right, we got two values for x. But just let's explore this a little more, because it doesn't look like we have a parabola here. This would be a parabola, and these are our two roots, right? This is a parabola. Right, this is a parabola. These are our two roots. This is a fairly familiar quadratic equation, but this here is not a quadratic equation. The original, right? This equals that. And okay, it's equivalent to a quadratic equation, but let's go look at GeoGebra. If I just type in the values here, the square root of x plus 1 is equal to the square root of all this 9x minus 2, I get a straight line. And that's at 9/16. And I don't see one at a quarter. That's funny. All right, well, not sure why that is. Let's try to just graph the equation, see what's y is equal to, what did we get? 64x squared minus 52x plus 9. Right? And it's a long, skinny parabola with roots at, predictably, 9/16 and a quarter. Well, so maybe these things aren't quite equivalent. If there's no vertical line at a quarter, and there is one at 9/16, well, let's just explore a little further. Say y is equal to the square root of x, and then add to that 1. And then the other side was y is equal to square root of 9x minus 2. And what do we get here? Put those guys up for a moment. Well, we've got two distinct square root functions, two distinct radical functions, and they do indeed cross right there at 9/16. Now, what's the deal with 1/4? Is that where this one starts? It is not. What happens at 1/4? I have no idea. But there's their intersection, so this would be the actual meaning, if there were any kind of real-world meaning beyond the tautology of some of the algebra. It would be that there's two radical functions and they cross at 1.75 on the y and 0.5625. Is that right? 9/16? 5625, that's right. On the x. So, at any rate, we looked at how radicals and exponents are related, and then an oddity when looking at this type of equality here, where there's got a radical statement equal to a radical statement. It looks like it turns into a quadratic, but then again it's not. So are both of these answers correct? Well, that's something for people with a whole lot of time to do mathematics, which I'm sure not most of us do. So this has been Dr. T's Maths. See you next time.